everybody. I am George, and in today's video I am going to show you useful tricks and techniques that will help you solve Sudokus in 0 time. Now you will see an example of an intermediate level Sudoku where we are going to apply all these techniques. This classical 9x9 Sudoku consists of 9 boxes 3x3. Here we have box 1, 2, 3, 4, 5, 6, 7, 8, and 9. In box 1, you can observe a pattern of parallel lines made by 4, 9, 3, and 5. You can also observe a T horizontally placed on the empty squares. The numbers 7 and 8 are controlling this vertical line. Thus, they can be solely placed on these two empty squares. But because of this 8, we cannot have an 8 on the same line, so we place an 8 here. Consequently, we can replace this X by a 7. Let's erase the notations, we don't need them more. So the numbers missing from box 1 are 1, 2, and 6. As you see, we can already place 1 at the first box. We have a 2 on the second line, so then follows 2 on the third line and 6 on the second. In box 9 we have the same pattern as we saw previously in box 1. 7 and 2 are placed on the empty column. The number 2 already exists in box 9, thus we must not place number 2 again. Number 7 can go here or here. Now we completed the first step of the solution, the pattern recognition. So we go on to the second step where we are going to search for each number by order, its place on the classical Sudoku. So we begin with number 1. We already have number 1 in the first 3 boxes, so we continue vertically. Number 1 goes to the center as the other ones occupy the other columns. Regarding boxes 4, 5, and 6, number 1 has these 4 potential boxes. It's something that I call the X hypothesis, because if 1 goes on the top left, it also goes to the bottom right, and exactly the opposite. We cannot make any progress here, however this can help us a lot. In these boxes, number 1 occupies the top line. Also, we know that surely in box 6 the empty line will be occupied by number 1. As you see, 1 also occupies this column, so 1 goes here and 7 goes to the other square. Number 2. We have a 2 on the second and on the third line, and also, another 2 occupy squares vertically. Number 2 obviously goes here. Regarding the first columns, 2 occupies this space and this square remains the only possible place for number 2. Now we observe the other columns on the right. We cross this column out, and this one, and now we cross out these lines, thus number 2 goes here. As you see, 1 goes on the top, as predicted by the X hypothesis. As we count the 2's on the 9x9 Sudoku, we conclude that number 2 mission is completed. So we move on to number 3. Summarily, number 3 occupies the boxes as indicated by the arrows and goes to the central square. It can be also placed in one of these 2 boxes, but we cannot decide in which of them it goes yet. As you can observe, in box 9 the first 2 columns are already full of numbers and the third one is empty. Also, in box 6 there is a 3 at the center. Consequently, 3 goes on the first box as in box 9 it can be placed solely on the empty column. Now let's take a look at the bottom. 3 has a place at the right bottom corner of the Sudoku. Now let's insert the last 2 3's. Obviously we place a 3 here, and here remains the only possible place for the last one. Easy. Right? So we go on with number 4. We use again the same logic in the first 3 boxes and we put number 4 here. Looking at the center, we observe that 4 can go now here or here. As we continue vertically, we eliminate all these squares and we put 4 here. Apparently, we have to put the other 4 here and then we continue with the pair at the center where we had doubt about where to put it. So here it goes, we completed the center and we go on with number 5. First of all, 5 must occupy the top right corner as another 5 occupies the empty square of box 3. 6 completes the box and it's done. 5 also goes here as you can easily understand. Now we count the numbers of the second box and without any problems, we finished the first 3 boxes. I think we forgot something. The center is also completed. We just place this 9 at the center. Now, another column gets occupied, as we can easily understand that 5 goes here. The 6th column of the Sudoku contains number 1, thus 1 completes that column. We count the numbers and we see that 6, 8, and 9 are missing. 6 has 2 potential positions to be placed. 8 has also 2 possible but different squares. 9 follows the same pattern, therefore we have a dilemma for each square. Nevertheless, we can already complete box 9, which can help us a lot. After placing 6 and 8, we definitely eliminate them from box 8. 6 can be solely placed here, 9 fits the line and 8 gives the end to number searching step in box 8. 9 also fits the bottom line. After completing the first 2 steps, we go on to the final step, which is a combination of the 2 previous ones but which also needs observability. It is called filling gaps stage. But we will also use step 2, as not all numbers are placed in. We can find a good example in box 7, where 1 number misses. Obviously, 5 fills the gap. We simultaneously filled a column and separated box 4 in 2 sections. Section B is occupied by 5, then we are sure that section A must contain it. We count the numbers and 6 misses. We spot the 6 and we put the other one here. We fill the gap with 7, completing the box, and then we complete the line with number 1. Now in 5th line, 5 and 7 are missing. We place them by order and they fill the line correctly. Here the X hypothesis helps us to place 9 and 8 in box 6, as there must be diagonal opposition. 9 is the last number, and now we completed our Sudoku successfully. Well done, guys. Write your impressions on comments below. If you liked this video, subscribe George's Riddle Academy on YouTube to watch more videos about Sudoku and other cognitive games. Your teenager champion teacher waits for you. See you soon. Goodbye.